Hi guys, hope you all are doing good. So in the previous videos we have learned how to insert a node at any position. So in this today's lecture we will learn how to delete a node from any position in a linked list. So without any delay, let's begin our today's lecture. So suppose we have a linked list. Suppose the linked list is 10, 20, 30, 40 and the null value. So this is our linked list. So now we want to delete the node at the position 3. So the node contains, yes, at the third position, node is 30. So after deletion, the linked list must be 10, 20, 40, and the null value. So how can we do it actually? So let us learn. So think about a line of students. Suppose we have lines of students. Suppose this is student 1, student 2, student 3, and student 4. So if student 3 left, he leaves the line. So student 3 will leave the line. So then the line becomes S1, S2, and S4. So student 2 should directly connect it to student 4 when student 3 left. So in the same way, linked list is gonna work exactly. So for the step 1, so for this deletion at any position of linked list, we need some steps. So first step is, the first step is we need to create two pointers. The two pointers are temp and delete node. So another way, another pointer. So delete node. So this is our node which we want to delete. So initially temp equal to head, and this delete node is not equal to anything. So we have declared two pointers, temp equal to head and delete a node. So temp will be help us to reach the node before the deletion position. So that's why we declare temp equal to head. So delete node will be, as I mentioned earlier, delete node will be is the which we're going to delete the node in the linked list. So on the next step, on the second step, we need to move to the previous node. So that means if position equal to 3. So let me write. So if our position equal to 3, so we must stop at the position 2, right? So let me write 10, 20, 30 and 40. So we want to delete 30 means we need to stop at 20. So for that we need a loop. So for that we are using a for loop. So initially int I equal to 1, I is less than position minus 1. So that means we are going to stop at the position 2. So this is the loop. So inside this loop we are going to write temp equal to temp of temp of next. Yes, correct. So temp of next. So now temp points to the node 20. So now temp points to the node 20. Yes, yes. Now the current situation it will be, so let me, so now temp will be start from the header. So then it becomes 10, 20, 30, 40 and the null value. So this is the current situation. On the step 3, we are going to store the node to be deleted. So for that we are going to write, so now we are going to write delete node, delete node equal to temp of next. Yes, we are going to delete node equal temp of next. So now delete node points to 30. So now delete node points to 30. On the step 4 we need to skip the node. So for that we need, for the skipping the node we need to write temp of next equal to delete node of next. So using this line we are going to skip the node. So now the linked list becomes 10, 20, 40 and a null value. So this is a linked list. So the node contains that is disconnected successfully. On the step 5 we are going to free the delete node. So we are going to free the node. So free delete node. We are going to free the delete node. Why we are written this? So deletion is successfully completed. We are using this free function because we are going to free the memory for deleting for the node delete node. So that's why we are written free node. So these are the three important lines. The first one is delete node equal to temp of next, and temp of next equal to delete of next, and free delete node. So these are the three important lines. So let me highlight with yellow color. So this line and this line and Let me scroll down. So these three lines are important for delete at any position. So now let us write on it. So first our linked list is 10, 20, 30, 40 and a null value. So this is the current linked list. So at the position 3 we need to delete the node. So position 3 is the deletion node. So we are going to move to the position 2, means we are decrementing the position. So we are moving to the move to position 2. So temp becomes 20. Store the delete node. So now delete node will become, delete points to the delete points to 30. So connect directly 20 to 40. So 20 will connect it. Let me write in diagrammatic way. So first let me erase it. So first initial 10, 20, 30, 40 and null. So here we are going to disconnect the joint 20 to 30. So for that we are just disconnecting. So we are writing in this way. So this connection also will be gone. So we are going to free the delete node. So this will become delete node. So we are going to delete this node. So this will be deleted. So now the linked list will be 10, 20, 40 and a null value. So this is all about the delete at any position of linked list. So let us see the C code. So I have already written the C code here, so you can see. So let me explain it line by line. So these two header files are very important. This can't be neglected. And we are declared a struct node with data and struct hashtag next, star next. So in the main function, we are declared head, second node, third node, and fourth node. And we have allocated dynamic memory for all of these four nodes, and we have given some values, head equal to 10 and second equal to 20, 30, 40. So in position equal to 3. So this is the position we want to delete. So we are declared temp equal to head as I mentioned earlier. So we are declared delete node. So we have written a for loop here which we want to stop at the before node. So int I equal to 1, I is less than position minus 1, I is incremented, temp equal to temp of next. So these three lines are important as I mentioned earlier. So these three lines are important. So delete node equal to temp of next equal to delete node of next, and free will, we are freeing the delete node. So then temp will become head. So we are using this while loop to print the all elements, all nodes in the linked list. So we are return the 0. So this is our output. So 10, 20, 40. So this is our output. So let me ask some questions about this deletion at any position. So why do we need the previous node? So why do we need previous node? Why do we need previous node to move the previous node? So we need this, why do we move previous node means because we need to change its next pointer. So we need previous node because to change the next pointer. So for that we need to need the previous node. So and the next question is why do we use this free? So why do we use actually free? Because means to return memory back to the system. So using this free variable we can delete the, we can allocate some, we can allocate the deleted memory from the linked list. So like that. So on the next question, this is a very important question: what is the time complexity for deletion at any position? So in the worst case, if we want the last node, means we want to traverse the entire array. So for that the time complexity will be, can you guess it? Yes, time complexity will be big often. So this is the time complexity. So this is all about the deletion at any position of a linked list. So this is all about the deletion of at any position of linked list. I hope this lecture is clear to everyone. If you have any doubts, you can ask in the comment section. So thanks for watching and see you guys in the next lecture.